Had a question concerning this problem, which is number 4 from the 2012 exam version A. You've got 3 blocks set up on an incline like this with a massless pulley with 2 ropes. I'll call the rope over here rope 1 and the rope over here rope 2. And you're trying to find the tension in rope 2. Now, with a problem of this sort, where you got multiple objects, there's always different ways to solve problems. I think the most general way is to approach this by looking at each little block individually and figuring out the forces on it. So I'm going to go ahead and first label the blocks. There's block A, block B, and block C. We'll start with block A. In the X direction for block A, there's going to be a tension here. I'm going to call it T2, since that's rope 2. Now, you would also have the normal force and the mg, but they don't really play a part in this problem, so I'm just not going to draw them so that we don't get too crazy of a picture here. For block B, I'm going to have that same tension T2 going backwards. Now, over here, we're told that this is a massless pulley, so the mass of this guy equals 0. So what I can say is that here, T1 is going to be the same. I can just draw it over here on this guy as T2. So the tension in this rope will be the same because that's a massless pulley. And so for block B, I've got a T1 pulling in the right direction and T2 in the left. And finally, for block C, I've got that T1 I mentioned. And then, of course, we've got gravity going downwards. Now, the trick here is that because these are all set up with this, with the ropes here, that they're all going to have the same acceleration. And so that's sort of our key. So we have 3 unknowns, T1, T2, and A. And so I'm going to set up my equations. And so I'll do f of x for block A. And of course, since it's got a mass of m and its acceleration is A, it's going to have an equation like this here. The only force in the x direction acting on that guy is T2. So that's my first equation. If I do the same thing for block B, equals ma, I get positive T1 minus T2 equals ma. And finally, I'm going to look at block C. Now, block C, the motion is in the y direction, but it still equals ma. And so I'm just going to say, you can do it different ways. I'm going to call positive y to be downwards. And so right here, for my equation, I'll get mg minus T1 equals ma. So those are our 3 equations of motion. Now, if you want to stop it here, basically what you want to go through now is you have 3 equations. You want to solve for T2, so it's just some algebra. So if you want to stop and try it yourself, please go ahead. What I would do is I would first take this guy and solve for T1. So T1 will equal mg minus ma. And then what I'm going to do is I'm going to plug T2 and T1 into my equation over here, where I have T1 and T2. So I'll write that over here. T1 minus T2 equals ma. Now for T1, I've just got it's mg minus ma. And then for T2, it's ma, and that equals another term of ma. And so if you take this equation and bring all the pieces with a on the one side, you get mg equals 3ma. And physically, what that means is what's going on here is basically, if you think about in the direction of motion, the tensions kind of cancel, and the force that's really responsible for the motion here is the mg. And so the mg is the one force that doesn't have something else counteracting it, and then it's moving a mass of 3m. So you can think about it that way too. You cancel out the m's, and I get my acceleration is g divided by 3. It's like we were saying, it's kind of algebra at this point. And so to solve for T2, I go back to my T2 equation and plug in, and you get mg divided by 3.